have a ruler that is greatly magnified so that you can see it on the camera. So pretend this is a standard metric ruler. This is centimeters. So 0 centimeters, 1 centimeters. So these are 1/10 of a centimeter, which you could also call a millimeter. We're going to count them as tenths. Here's the object that we want to measure. We've started by lining it up with a 0, and we can see that the object ends in between 1.2 and 1.3. So we talked about in the last video that we're measuring this centimeter exactly. We know for sure that this is at least 1 centimeter long. We also talked about that we're measuring this tenths place exactly. We know for sure it's between 1.2 and 1.3, so we know for sure it's 1.2 something. Now, we can also tell that it's a little bit closer to 1.2 than 1.3, so we estimated that this was 1.24 centimeters. So remember, I know this one exactly, it's exact, this one is exact, and this one is a good estimate. All three of those digits tell us something about the measurement. So we say all three of those digits are significant. So here we would say that there are 3 significant figures. Or some people would say that there are 3 significant digits. Now, if you look at a measurement and there are numbers recorded, it's easy to tell if they're significant if they are numbers other than 0. Clearly, this is something we measured because we wrote it down. However, sometimes we write down a 0 that we did not measure. We write down a 0 that is just acting as a placeholder. So we need to know when the 0 is acting as a placeholder and when it's something that we actually measured. So we're going to talk about rules to tell if zeros are significant. Now, a lot of books and a lot of teachers will give you a list of rules and ask you to memorize them to know whether or not the zeros are significant. That works great. If you want to memorize these rules, it will get you the answer. But I really prefer that you understand why these rules are the rules. If you understand that, 1, you'll have a better idea of what we mean by significant figures. 2, it makes it easier to remember the rules. So let me give you some examples to show whether or not zeros are significant. And let's start with this measurement that we just made. So the length of this rectangle is 1.24 centimeters. Let's take a second and do a unit conversion. So let's say for whatever reason we want to convert this to the SI unit. We want to convert it from centimeters into meters. We know how to do that by unit analysis. And we know that 1 meter is 100 centimeters. 100 cents in a dollar, 100 years in a century, 100 centimeters in a meter. Those units cancel, we're going to get meters. And when we divide by 100, we just move the decimal 2 places back. So we end up here with 0.0124 meters. I now want to talk about this number and compare it to that. I want you to note that they are the same measurement. We measured the centimeter. We measured the 1/10 of a centimeter, and we estimated the 100th of a centimeter. All of these are things that we measured. But we did not measure this 0. This 0 is there simply to hold a place. It's not something that tells us about our measurement. This 0 is not significant. And that leads us into our first rule for significant figures. Leading zeros, zeros that are in the front, are never significant. They are only there to hold a place. So since they are acting only as placeholders, they are not significant. Now, to explain these next 2 rules, I'm going to need to look at a different example. So let's go up to our picture and let's slightly change the length of our object. I'm going to make this object shorter. I'm now going to stop my object, right there. So let's say we want to make this measurement. I can tell for sure that it's more than 1 centimeter. I can also tell for sure that this is in between 1 and 1.1. So I know that this is at least 1.1 centimeter, pardon me, at least 1 centimeter, but not quite 1.1. So I want to estimate. Well, it's way closer to 1.1 than it is 1, so I'm going to estimate that it is 1.09 centimeters. Notice have a 0 in my measurement. Now the question is this 0 significant? And the answer is going to be based on whether or not it's something I actually measured. Notice, on my ruler I can measure the whole centimeter. I measured that. I can also on my ruler read the 1/10 of a centimeter, and since that's in the tenths place, I can measure that. I know for sure it's 1.0 something. And this one is a good estimate. It's closer to 1.1 than to 1.0, so 1.09. So if I measured this and I measured that, clearly I measured the one that is in between, which leads to our second rule. Included zeros, and what I mean by included is zeros between other things that are significant, are always significant. Because if I measured this and I measured that, certainly I measured the one in between. So if I were counting my significant figures here, this has 3 significant figures, 3 significant digits. Okay, so rule 1 should make sense. Leading zeros are placeholders. They're not significant. Included zeros are between things that we measured, so we must have also measured that. They're always significant. The rule that tends to give people the most trouble is the last rule, trailing zeros. And the reason that they give people the most trouble is sometimes they are significant and sometimes they are not. Okay? So the question is going to be whether or not it is a placeholder. Okay? So, let me give you an example here without measuring. Let me give you an example from doing a conversion. So let's say I start off and I have a measurement here. That is 1.3 meters. So I measured this exactly. I know it's at least a meter, and I estimated this. It's in between 1.2 and 1.4 meters. I guessed 1.3. So this is something I measured. This is my estimate. Both of these digits are significant. So this has 2 significant figures. Let's do a quick unit conversion and say I want to change this to millimeters. So 1.3 meters, I'm going to get rid of meters and switch it to millimeters. Now remember, milli is 1,000. There's 1,000 years in a millennium. So there are 1,000 millimeters in a meter. So if I multiply this, I find that this is 1,300 millimeters. Notice, this is the same measurement as that. I measured the meter. I measured, or I estimated the 1/10 of the meter. But I did not measure these. These are here solely as placeholders because of my unit conversion. So these don't tell me anything about the measurement. They are not significant. So my rule here says trailing zeros are significant if there's a decimal. Notice, I did not bother to write down a decimal in this measurement. There's not a decimal here. So if there's not a decimal, these are not significant. If there is a decimal, they are significant. If there's not a decimal, they are not significant. So this has 2 significant figures. Exactly the same as this one, which has 2 significant figures. Well, let me give you an example of when we would put a 0 with a decimal to show you why it is significant. So let's go back to our ruler and our measurement, and let's make this just a little bit longer so that it looks like it ends exactly on this 1.1. Now, I want to point out that when we were reading this ruler, we could read the whole centimeter exactly. We could also read the 1/10 of a centimeter exactly, which meant we could estimate to the 100th of a centimeter. Well, if we look at this measurement, we know it's 1 exactly, and it looks like it's right on 1.1. But we can estimate the 100th. But since it's right on the 100th, we want to specify that by saying that it is 1.10 centimeters. Now, in math class, you would never write 1.10. You would just write 1.1. Why would a scientist take the time to write down that 0? The only reason he would write down that 0 is to tell you that it is significant, to tell you that it's something that he measured. It's not just a placeholder. So we measured the ones, we measured the tenths, we estimated the hundredths. So notice that 0, it's trailing, it's at the end, and it's after a decimal. So if there is a trailing 0 and there's a decimal, then it is significant. So this measurement has 3 significant figures.